All right, physics students, it is Monday, March 23rd, 2020. So your video today, I'm trying to show you a lab. So this is a lab that you would have been doing. I haven't been able to figure out really a good way. I think you could do it at home. So I'm going to show you the lab and I'm going to send you some data. So I have here a cart. And the cart is attached by a string to a mass hanging on the end of the pulley. And right now the cart is blocked in place, but if I take that away, you see the cart accelerates. We're going to look for, in part one of this lab, is there a relationship between the acceleration of the cart. We're going to keep the mass on the end of the pulley always the same. But we're going to add masses to the cart. So I said that kind of funny, but what we're looking for is there a relationship between the acceleration of the cart and the mass that's stacked on the cart given a constant force? So all of this setup is about trying to measure the acceleration. So this device here with the black and clear stripes is called a picket fence. And you see I actually have a photo gate attached to the cart. So when the cart rolls through, the photo gate's going to pass by the picket fence. And of course, every time that there's a black stripe, it's going to block the light, and then the clear stripe is going to transmit. Block, transmit, block, transmit, block, transmit. As it goes through, it's going to accelerate. And so that data is all going into my Chromebook and the graphical analysis software, and I'll be collecting some information. I'm not sure if this is going to show up, but I'll show the screen. Now, usually we had to just take our times and figure out what our velocities were and our accelerations. In this case, those stripes on the picket fence are the distance that the program was preset with. And so when we get to this acceleration column here, the acceleration values that are in here should be accurate. The computer should be calculating based on the distance and time that it's pre-programmed with what their accelerations are. So if I have a list of accelerations, because it's going to measure for every couple of blocks or stripes, it's going to get a new acceleration value. I can average the accelerations I have here and have a pretty good idea of the acceleration of my cart. So all of this is about measuring acceleration. What I'm going to do is put my camera on a tripod and get to collecting some data. Alright, so hopefully you can see things okay. More importantly, can you hear me? So for trial one, I want you to know there is a 200 gram mass on the end of the cart. 200 grams. For part one of this lab, I am not going to change that. 200 grams on the end. For the first trial, I'm going to have just the cart. And I just remembered that we're going to need to know the mass of the cart. Let's get it right now. So here's the triple beam balance. I'm going to temporarily disconnect my photo gate. I'm going to put my cart on the balance. And if I go all the way up 500 grams plus 100 plus 10, it obviously didn't affect that at all yet. But what I have on the triple beam, there's these extra masses, and if I hang them right on this end where they're designated, that represents an extra 1,000 grams. So now there's 1500, and 1500 just tipped it. So I'm going to go back to 1400. Here's 1490, and it's not quite enough. 1491, 1492. Seems to me that's a fairly famous year from history, 1492. I am not going to worry about the tenths of a gram on here, because within the sig figs of what we're doing, it's not going to matter. So I have 1,492 grams is the mass of my cart, or in other words, 1.492 kilograms. You're going to want to record that, 1.492 kilograms. Hook my photo gate back up. Hopefully I have a green light on my LabQuest. Yes, I do. Hang this mass off the end. Just kind of check that we're lined up. Looks pretty good. So, trial one. Oh, gotta wake up my Chromebook. It keeps wanting to go back to a graph, and I just want the table on here. So, it's ready for data set 1. I'm going to hit collect. And go. And I'm going to check my data. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My time data, it's showing me it's gone through 8 on and off cycles. I have 16 pieces of time data, so it's open and closed 8 times. I have more than that on this, and what I'm wondering is the original picket fence that comes from the company, I think only has 8 bars. I made this one myself, so it had more. I think I'm going to go ahead and just use what it's got here. I'm going to send it this rather than trying to redo and figure things out. So I'm going to back this up. By the way, that was, again, the empty cart. So now I'm going to do a trial 2 with the same weight on the end of the string. We've got 200 grams on the end of the string. I'm going to tell the computer to collect. I am putting an extra kilogram on my cart. So this is the cart plus 1 kilogram. And go. Okay, when we look at our data, I believe the newest data is data set 2. I just wanted to make sure which order the computer is doing this. So you can help me remember the first acceleration value in data set 1 is 0.84, and the second one's in the second set it's 0.51, so we'll check on this one. This next trial, I'm going to do 2 kilograms on the cart. And go. Notice I do not stop it until we're after that last gate. Yes, you can verify, or I can verify for you, when you look at your data, the data trials are in order. So when I said that was trial 3, it's showing on your chart as set 3. Because my intent is to share that data with you. So I'm going to hit collect. This is going to be our 4th trial. And our 4th trial is going to have the cart plus 3 kilograms. And go. Getting ready for our 5th trial. Our 5th trial is going to be the cart plus 4 kilograms. If you notice how I have this wire up here, the wire for my sensor, I have it looped so that it doesn't get in the way of the wheels and is free to move. I think that's important. Okay. This is going to be our 6th trial. Weight came off the pulley. Just that. So the 6th trial is going to have the cart plus 5 kilograms. And go. I think we'll get one more out of here. I've got one more 1 kilogram mass. So this will be trial 7. Trial 7 is the cart plus 6 kilograms of mass. And go. Okay. So what I'm going to do is I'm going to stop my video here. This was part 1. You heard what I did for the different trials. So basically, what are our measurements here? I change the mass of the cart each time. So you should be able to get the mass of the cart for each of my trials. And we're measuring the acceleration. So all this data I send you is going to be about trying to get the acceleration of the cart. My suggestion would be to find the average acceleration. So I would say in our lab report, you always should have original data. If you don't want to include all of this original data, or maybe you tuck this on page 2 of your spreadsheet or something like that, but you probably should have a summary of your acceleration data in your regular report, because that's what we were measuring here. We were using this to measure accelerations, and then if you find the average acceleration, you're going to use that to finish up your report. One more thought. All right, so you need somewhere in this lab probably to find the force on the string. So I put a mass. It's a 200 gram mass. think what I'm going to do is take the camera